fast is the switching. Basically, there's IGBT here. So IGBT are controlling firing. So the firing, how high is the speed? For your understanding, if you're talking about PWM, how high the speed can pick up? The switching speed on the IGBT side. Okay, we're talking about motor. Motor is a 50 Hz only. But everybody know how fast is the IGBT switching? On your school, I think they didn't learn about this. You only control the switching on the gate. But how fast is the switching?
Instantaneous.
What?
Instantaneous.
Not to say instantaneous, there must have a value. So inverter usually
100 milliseconds.
No, speed. Switching.
Switching speed.
Hertz.
In hertz.
The frequency switching speed.
How many hertz?
How many hertz per second? For your concept, low-end inverter, you're talking about 2000 hertz. 2 kilohertz. For normal Siemens inverter, we talk about 4000 to 16,000 hertz. Yes, imagine the IGBT switching 4,000 times per second. Yeah, with low-end drive, 2 kilohertz. The higher the hertz, the better the control, but also higher the energy consumption. Dia lagi cepat but standard inverter for Siemens one usually can up to 16 hertz. 16 hertz. But commonly our setting maximum 4 to 8. Very seldom we set up to 16. General default setting usually is 4,000 hertz. Okay, sometimes we might need to tune the hertz, but most of the time for general application we no need to tune, no need to change alter the frequency setting. Okay, so basically this is advantages for control wise. Adjust speed control. There's a dynamic torque control. They can control stopping and stopping acceleration, provide smooth motion, reduce mechanical stress, blah blah blah. Okay, just now we talked about starting torque. Okay, the best in the class, short starter. We talked about 4 to 7. Inverter how many? Not in your slide. General just general. Usually the peak current is talking about 2 times only. 1.5 to 2. Because already they're doing the power conversion. Okay? And another tricky thing, basically, usually, this is input, this is output. Like example, your running output is 30 kilowatts, 60 amps. But your input usually it should be lower. Because all the stress is on all the M is generated from here. So your input and output current will be different. When we talk about energy saving, basically this is where the energy saving. And also there's all the fluctuation current is stored on the DC inside. They're not going to generate back to the input side. So usually the input side very stable, the current. Okay? When you talk about DOL, the power factor is how many? When you're running a motor, efficiency, usually one motor efficiency depends on the I class. Efficiency usually about 89%, or maybe sometimes 85%. For low, if I2 minimum is about 90, I3 up to 95, IE4 98%. So when you generate 10 amps, there will be about 10% energy will be converted like heat and vibration, all those things. Okay, there is a waste energy. So like inverter, usually no waste energy. Just they will have provide some harmonic back to your backlit line. Your harmonic also will causing your power factor THDI we call total harmonic distortion current. They will interruption the power factor. Definitely, the low power factor will cause higher consumption. They want too deep.
So they will have harmonic filter.
Okay, this is application consumption, the limit and solution. So basically, there is a disadvantages we will available when using inverter. The first one, line harmonics. Okay, so basically this line harmonic, when you're doing power portion, there will see there will have some harmonic current that will generated from the circuit. Okay, the bigger the inverter, the bigger the value, they're going to generate ADI. Okay, the design will causing loss and overheating and shorten the operation time. Okay, the simply say they'll there will generate some noise on your sound wave. Jangan ada noise lah. Senang cakap lah, ada noise. Not only the inverter itself, they will backfeed to the power line. Means the whole line will affected. Kalau you tengok you affected, memang fluctuate ni. So, untuk kalau harmoni tinggi, you jalan motor biasa pun you akan dengar suara. Ingin. That means suara tak sama, tak stable. Usually this is causing by cat line. So usually when new industry will kick in, usually they will having the line harmonic filter control. Passive type or active type to reduce harmonic. Usually if you reduce 10%, below 10% or below 5%. Susah lah nak control tu lah. Biasa dia akan try to reduce, dia tak boleh eliminate. Memang ada. Lagi banyak inverter pakai, lagi tinggi ya harmonic ada. Tapi biasa kalau home application usually they come with a live filter. Okay, then IFI EMC. This is the sound that you heard, causing by the EMC. Okay, so kenapa you boleh dengar suara tu? Sebab ni, sebab EMC and IFI. So they're causing issue and nearly the equipment and also immediate failure to other equipment. So this EMC is not only on the drive itself, they will affect the component nearby the drive. Okay, the energy magnetic. There's another we having one issue at side. They're having a microwave effect. Mean the panel sebelah tu kabel panas sebab inverter. Sebab dua current jalan, dua magnetic kacau. Ada. They create like something like microwave effect. Dia akan panaskan kompartmen sebelah ataupun dia tengok drive tak panas tapi papan tepi tu panas. Ini selalu jadi.
Kalau begitu rapat lah.
Terlalu rapat ataupun dia punya noise terlalu tinggi, dia akan affect daripada sebelah. Ada possibility. Bukan terpaksa dia akan jadi, tapi ada possibility. Ada possibility. Memang pernah jadi kat site 400 kW ni inverter yang besar. Tapi kabel tepi yang bakar, bukan dia bakar. Check inverter ni issue. Okay, then noise, switching frequency, they're creating acoustic noise. Memang akan ada lah. Tak kisah drive dengan motor, dua ada. And also long cable. Due to the inverter, because if you're using starter, we always fit minimum soft starter, minimum 40% voltage. So imagine I got a 500 km cables. Okay, if you're using soft starter, you're still able to run the motor. Because my start voltage got 40%, but inverter cannot. Inverter my start voltage can be 10%, 5%. So the cable resistance will causing the capacitor overcharge. Means my voltage macam mana IB inverter bagi voltage, tak sampai motor tak patah balik. Okay, they will create some high current and also overcharge my DC. Okay, so usually when using inverter, the cable calculation is very important. Most of the maker, tengok dia consultant, dia orang kira motor cable pakai dual je. Duality mean I calculate the motor cable length. Oh, this cable length usually when the motor is overlap, we need to upsize the cable to reduce the resistance. Tapi I selalu jadi kat site, dia pakai dual punya calculation untuk inverter motor. Kena lah. Tak boleh lah. Selalu jadi.
So solution ni dia tukar kabel lah.
Kena upsize.
Upsize maksudnya tukar kabel terus.
Inverter kena upsize. Macam ada case kabel sekarang tu 0.75 kW, motor 700 meter, 0.7 kW, my motor less than 2 amp. Imagine I need to fit 2 amp less than 10 volt to the motor through a 700 meter cable. Do you think is make sense? Make sense lah, walaupun dia tambah filter. Okay, to reduce it usually we add a sine filter. Means we make the PWM become more sine wave so that they can transmit further. Usually we add some filter and also a motor very current. So the PWM you're causing a high frequency common mode voltage, causing trouble to the bearing. Kenapa? Usually this will causing some leakage. Selalu kalau inverter duty punya motor dengan normal duty motor tak sama. Different motor. Usually for inverter duty motor, they will add additional insulation on the bearing. Mean the bearing is not touching the body to reduce this voltage. So this cause the high frequency common mode voltage. Basically, apa akan jadi? Masa motor jalan tu, bearing ada spark.
Jadi dia kena support lah.
Yeah, they keep on spark. So spark. Okay, bearing minyak kering, bearing rosak. Ini memang, ni pun selalu jadi. Selalu jadi, betul. So inverter duty motor, usually the motor application also different. For our testing purpose, we use the normal motor. But for site, usually inverter duty and UL duty, the motor is different. There was an additional insulation on the bearing side. Mean the bearing, the rotor and stator is fully isolated. Okay? Something like that. The concept is something like that. Selalu jadi. Sebab ada consider ni causing there common mode. There the water are causing trouble to the bearing. Causing trouble already mean terbakar dia. Daripada panas lah, lama-lama panas. Itu kenapa kalau inverter, kalau motor besar, biasa dia bukan monitor core voltage, core temperature, dia monitor sekali bearing temperature. Okay? Because of the liquid current can cause the bearing lubricant dry easily lah. Create high temp lah. Senang cakap high temp lah. High temp, lama-lama minyak tu terbakar. Bearing tu memang keras lah. Lama-lama rosak. Sampai bearing rosak lah. Ataupun mechanical failure lah. Okay. Okay. This is the semi family. Basically semi family 3 je. Tapi dalam ni 3 pun banyak gila. So there's a V series, G series, S series. V stand for variable. Basically this is a basic drive. Basic drive. Variable stand for basically dia pakai untuk apa? Single phase. Untuk biasa commercial pakai. Contoh nak pasang exhaust fan ke apa, okay, boleh pakai ini. Basic ni, paling basic ni. Walaupun dia mahal juga lah sebab single kan. Walaupun dia basic tapi mahal juga. But this application basically used for high degree of rugged condition. Ini boleh letak indoor kan, letak dinding ni. Pakai terus. Saya pernah pakai ni untuk kitchen hood ni. Ni exhaust. Dia pakai ni. Ini dia ada additional coating kepada board dia semua. So dia extra rugged compared to ceramic G. Okay, but this application basically mostly used for the basic, super basic application. They only use this series. Okay, we talk about G. G is a general. Basically, it's a general series. One of the also is most in the market. Also very common their model. Okay, so ceramic G function basically they will cover for low and medium voltage demand on the dynamic response. Okay, when in electrical world, when we're talking about low voltage is not talking about 24 watt, 12 watt. No. Okay, that one you call ultra low voltage. When talking about low voltage, means below 1000. 415, 690 is under low voltage category. Medium voltage we talk about below 33 kV. 33 kV. Okay, for inverter, usually up to 11 kV drive. Biasa oil and gas kalau nampak lah. But commonly in the market 6.6, 6.6 kV. Kalau selama ni tengok TMP kan, TMP punya substation biasa 11 kV. 6.6, 3.3, 11, 33. Night 67, night 132. Okay? So basically for simple inverter, G series they up to 11 kV. And next, Dynamic S series. Step. Smart lah. Okay, basically S series is for vector control, servo control. Okay, so ini untuk high end punya drive lah. High end category. This is medium and medium high range. This cover basic, low range. 3 je. So dalam B series ni ada dalam B pun ada servo, basic servo. So in B series we got V20, V50, V90. V20 is a general drive, V50, V90 is a basic servo drive. Okay, Dynamic G series. When you talk about G series, you got a lot. Okay, in G10, G120 je, ada C, ada P, ada X, ada D, ada G. Macam ni. But senang ingat 220, 120. Okay, in further that we got 130 and 150. 130, 150 basically is a motor more than 300 kilowatts. Besar-besar, sampai besar kabinet. Atau besar berapa kabinet. Paling besar sampai 8 kabinet besar ni. Satu motor, 8 kabinet. Untuk satu motor. Sebiji motor je, 1.2 kilowatt, 8 biji. 8 cubicle. Sampai sini sampai sana. Satu motor. Okay, S series basically is cover for S120, S150, and then furthermore S210, S220. And 210, 220 basically is under B. Basic servo, but they categorized under S. Okay? Okay, ini yang untuk overview for Dynamic G family. Okay, basically Dynamic G family ada banyak ni. 120C, 120 dengan X. And furthermore, we got G220, 220 at the back. 220 tu baru ni, paling baru ni. So common biasa kita pakai 120. So 120 cover point 0.55 sampai 200 Okay. Furthermore, we got G130 and G150. G130 is a chassis type or there's a cubicle type. G130 130. Okay, sampai 2.7 kilowatt. 2,700 kilowatt, 2.7 megawatt. Ini megawatt lah. Tapi I tak pernah bak main lagi dah sampai 2 megawatt lah. Paling besar 1 bulu. 1 bulu tu besar ni lah. Imagine 2 megawatt berapa besar. Biasa rubber industry, stone industry, ataupun buat simen, buat apa lah, ada. Simen industry ya memang ada. Biasa motor besar-besar. Untuk hancur batu ke, untuk blower ke. So G130X, basically X series ni ialah ini dia basic, cheaper version. Cheaper version. But basically this is for HVAC features, HVAC. HVAC features in the industry we call, that's why they're under industry specific. This is mainly for HVAC. HVAC you see, H heater, V ventilation. Air is air conditioner and cooling. HVAC. Okay. So HVAC, when we talk about HVAC, means it's a basic. Biasalah untuk heater, untuk ventilation, untuk aircon je. Untuk kilang dia ventilation. Not for process. You can use for process, but usually their recommendation for HVAC features. Okay, and G180. G180 ni special application. Ini harmonic drive. Tapi jarang pakai. Europe banyak. US banyak, Europe tak. US banyak pakai. Tapi Malaysia I pernah pakai sekali pun. So far. Out 10 years lah. Okay, so G180 pun sampai cover sampai MV, medium voltage. Ini specification of the G120C. Okay, G180